the science that relates to heat and temperature is physics, but it seems that physicists have been left out of the equation, so to speak. Climatologists have invented their own brand of physics and taught it among themselves in a one-year course, and they have not consulted physicists who are duly qualified and can understand such things as entropy and thermodynamics and radiative heat transfer. We now know, for example, in the 21st century, that the energy in radiation, which is electromagnetic energy, is not always converted to thermal energy, which colloquially we call heat, when it strikes some target. In fact, if that target is hotter than the source of the radiation, there is no conversion to thermal energy at all. This is where they go wrong. NASA originally put out a climate diagram, and an energy diagram as they called it, and it showed the sun warming the earth with its radiation, and then warm air rising and creating this temperature gradient, or lapse rate as they call it, in the lower part of the atmosphere called the troposphere. It gets colder by about 6 or 7 degrees for every kilometre that you rise above the surface. And they thought that's how it happened, until they realised, using the equations of physics, the Stefan Boltzmann law as it's called, that the amount of radiation that the sun delivers actually to the Earth's surface after sun has been reflected and absorbed in the atmosphere is nowhere near sufficient to explain the average global mean surface temperature of the Earth, not even within 50 degrees or more. It simply cannot explain it. That might seem strange to you because you stand in the sun and you think it's warming you, but the sun is only directly overhead a very small portion of the Earth at any one time, and when you take the average, you can only achieve a temperature of less than minus 40 degrees centigrade. You can see on the moon that the average temperature is in fact well below zero also, even though the moon's surface receives about twice as much direct solar radiation as the Earth's surface does. So it's not the sun's radiation that is heating the Earth. So NASA thought, oh well, it must be radiation from the atmosphere. And they took out from their website the diagrams that showed the sun supposedly hitting the Earth, and they added what they called back radiation, radiation from the atmosphere. And in fact about twice as much as there was solar radiation. Now this is simply just not valid physics. You cannot add to the solar radiation the radiation from the atmosphere to get the temperature that you'd expect. The temperature at the surface of the Earth and the surface of Venus is not determined by radiation, especially on Venus, where the amount of solar radiation is only about 1/8 of the sun's rays that strike Earth. So there's no way that the temperatures of around 460 degrees C on Venus can be explained by direct solar radiation to the surface. And nor can they be explained by radiation from the atmosphere, because even though the atmosphere gets hot near the surface of Venus, it still cannot radiate as much energy into the surface as the surface is radiating out. Whenever there's a hot place and a cool place, the heat transfer is always from the hot to the cold by radiation. So how does the required energy get into the surface of Venus in particular, and in Earth as well, to explain the average temperature? Yes, on Earth, solar radiation does warm certain small sections of the Earth, and they cool off fairly quickly, but then they start to slow down cooling when it gets to the night, and especially by the early hours of the morning, before dawn. The cooling just about stops. Now think about that, because it cools by many degrees, several degrees anyway, per hour after a very hot day in the afternoon, but it doesn't keep cooling. And that's because it sort of hits a supporting temperature that's supported by the atmosphere, not by greenhouse gases in the atmosphere, but by nitrogen and oxygen and argon and all the gases in the atmosphere that contain energy. And the reason that this happens is because the effect of gravity is to set up a temperature gradient in the troposphere, making it warmer at the base of the troposphere than it is higher up. This was actually first explained by a well-known and very professional, very experienced and competent physicist Joseph Loschmidt in 1876. He was the first to realistically determine the size of air molecules, which was quite a feat in those days. He was a brilliant physicist. And he realised that gravity would act on molecules and would speed them up as they went downwards and slow them up as they went upwards. And the speed tells us the temperature on a macro basis. So this is how the temperature gradient is set up. But we've known that for a long time, or at least physicists have. Climatologists completely ignored it. And they thought that there'd be no differences in temperatures in the troposphere if there weren't these greenhouse gases which were supposedly sending energy to the surface, thermal energy to the surface, and raising the surface temperature with their radiation from the cold atmosphere. And that simply cannot happen. So what does happen? We still haven't answered the question, how does the actual required heat, thermal energy we should call it, get into the surface? Now let's consider Venus, because that's a nice clear-cut case, but a similar thing happens on Earth nearly all the time. On Venus, the solar radiation cannot raise temperatures above about 150 degrees C at the most. It's rather like how the solar radiation striking the surface of the Moon can only raise its temperature to about 121 or 2 degrees C. Venus a bit closer, gets more solar radiation. That would be around about the approximate temperature that the solar radiation reaching Venus could achieve. And it can only achieve that, it can only raise temperatures way up in the atmosphere that are down around that sort of temperature. They get far hotter as you approach the surface. So our new energy each day is being absorbed and raising the temperature on Venus only in these areas in the upper atmosphere. How does that energy get down to the surface? Because we know that the surface of Venus does in fact rise by about 5 degrees or so over the course of its daytime, which extends roughly 4 months of Earth time. You see, it must cool off on the dark side, and so it must warm up again. You might dispute the 5 degrees figure, but there must be some warming on the sunlit side. Some of the energy from the sun must be getting down to the surface. Think about it. That means the energy is going from a less hot region to a hotter region. And you probably think your schoolboy physics tells you that can't happen. But it can. We're talking about what's called the second law of thermodynamics in physics. A simple form of the thermodynamics law is that heat does go from just hot to cold. But that is only always true for energy that's transferred by non-radiative processes in a horizontal plane. When you have gravity coming into the picture over a range of altitudes, the whole thing changes. Because remember, gravity has set up this temperature gradient, which is actually the state of what we call thermodynamic equilibrium. You can think of this temperature gradient, if you can imagine a graph of it, as being the equivalent of a level lake. When rainwater falls on a part of a level lake, gravity spreads it out over the rest of the lake. In the same sort of way, when new thermal energy is absorbed in the upper atmosphere from the new solar radiation at the beginning of each day and raises the temperature in the upper atmosphere, it disturbs this state of equilibrium. It's like rainwater falling on one edge of the lake. The new energy spreads out in all directions, because what happens is that if you can imagine that graph of temperature against altitude, which is not a level line, it's got a slope to it, it will rise to a new but parallel position. So if energy is being added to the top of the atmosphere, some of that energy has to go downwards in order to raise the lower parts of that graph of temperature up to its new parallel position. Gravity will keep ensuring that the gradient will tend to return to its normal form, its normal value. And if there was no radiation within the atmosphere, that value, that gradient, would be about 9.8 centigrade degrees per kilometre. But we know that water vapour reduces the gradient. Climatologists think it's entirely due to the release of what they call latent heat, when the water evaporates from the ocean and subsequently it condenses again. That plays some part, But a major part, I believe, is caused by the fact that whenever you have two bodies at different temperatures radiating towards each other, there's a tendency for the temperatures to level out. So there's going to be radiation between greenhouse molecules of the same type. Most of these greenhouse gases are water vapour, some carbon dioxide, yes. But in each case, the radiation properties of these gases is tending to level out the temperature gradient caused by gravity. But it doesn't get all the way, because these gases only make up a very small percentage of the actual atmosphere. In fact, carbon dioxide is only one molecule in every 2,500 molecules. Water vapour can vary between 1 and 4%. Now, we would expect this levelling of the temperature gradient then to reduce the surface temperature, and it does. Because remember, the temperature is set up in the atmosphere where the sun can raise the temperature and support it at a certain level. And from there the temperature rises due to gravity. But if it doesn't rise as much because the gradient is less, it will only meet the surface at a lower temperature. And in fact, that's why greenhouse gases actually cool the surface. And in my paper called Planetary Core and Surface Temperatures, I wrote in 2013, there's also a study in the appendix which shows that in fact the wetter regions do have lower mean daily maximum and minimum temperatures than do the drier regions, other things being equal. Now you can read my papers, they're all linked from a website, whyitsnotco2.com. WHYITSNOTCO figure 2.com. So have a look at that, read the papers, and I assure you that the physics therein is correct. And of course this has huge ramifications. I believe many climatologists and people realise that it is wrong. Over 30,000 scientists have signed a petition saying that it's wrong, that mankind does not cause global warming. What does? Well, there's now evidence that variations in cosmic rays cause variations in cloud cover, and those, of course, affect the temperature at the surface because clouds reflect energy back to space, they shade the Earth. How do the variations happen? Well, as sunspots vary, the region called the heliosphere varies, and that tends to prevent cosmic rays entering the inner solar system, or allow more of them, depending which way. So sunspot activity can affect cosmic rays, which can affect climate. I also believe that the magnetic fields of the planets reach to the sun, and they could divert the paths of cosmic rays so that more or less reach Earth depending on the positions of the planets. And there's some evidence that long-term climate cycles are related to planetary orbits and solar activity. So we have these natural cycles. There's a fairly evident one of about 1,000 years. It was warmer in Roman times a couple of thousand years back, and again in medieval warming period. Cooler in the periods in between, the Dark Ages and what we call the Little Ice Age. And now we're close to another maximum, which could well turn to 500 years or so of cooling sometime later this century if it hasn't already done so. There's a superimposed 60-year cycle which was rising until 1998, and that caused alarm because both cycles were rising. But now that's been going down, and the net effect is very, very little. If you look at the satellite figures on the website by drroyspencer.com, you'll see that in his red line of moving averages, the peak in 2016 was only 1/20th of a degree above the peak in 1998. Very little warming, which is now probably starting to turn to cooling. There may be some more warming after about 2028 for 30 years, but sooner or later the world will cool, and the amount of future warming is very likely to be less than half a degree. So present to your friends this information, send them a link to my website, speak up, and don't support what has become the greatest deception in the history of the world. The claim that carbon dioxide is causing global warming. It doesn't.